Hi, geometry students. This is Mrs. Hefty here. We're starting chapter 2 today, and we're going to start with section 2-1, which is on inductive reasoning and conjectures. Let's first define what inductive reasoning is. It looks at a number of examples or situations and comes up with a conclusion, is what you're doing. That conclusion is called a conjecture. So the concluding statement that you reached using inductive reasoning is called a conjecture. So an example of that would be I'm eating pizza and I got a stomachache. And then the next time I ate pizza, I got a stomachache again. And then I ate it again and I got a stomachache. And so then after a few times, a few situations, I come to the conclusion that I'm going to get a stomachache whenever I eat pizza. So in that situation, I'm gathering a bunch of information and then I'm drawing a conclusion, kind of like what a detective would do. All right, so let's do this in math now. Write a conjecture for the following. So I have angle 1 and angle 2, and they form a right angle. Sometimes if you draw pictures, that will help you draw a conclusion. So what I need to do is I need to have a right angle, and I need 1 and 2 in it. So I'm going to draw a right angle here. I make that right angle marking. I got 2 angles. I got angle 1 and angle 2. So now when you look at that picture, I'm gathering information. What else can you say about angle 1 and angle 2? 1 and 2 are going to add up to 90 degrees because that's really what right angle means. So I'm going to write that down. Now when I'm talking about the angle, I'm talking about the measure of angle 1 plus the measure of angle 2, and that equals 90 degrees. A couple of things, people. When you're talking about the angle, you need to have the m's there because you're adding angle measurements up to equal 90 degrees. Could I have written angle 1, measure of angle 1 equals the measure of angle 2? When I gather information, I don't necessarily know. If I drew another picture here, could have went like this, and that could have been 1, and that could have been 2. So the information that I gather is not really going to produce that 1 and 2 are always going to be equal. So 1 equaling 2, measure of 1 equaling measure of 2, really is not a correct answer. Let's take a look at example number 2. I've got angle A, B, C, and angle D, B, E are vertical angles. So I've got A, B, C, and now I need DBE to be vertical angles. So this is A, this is B. So I'm going to extend those. Here's where B is. This is going to be D, and this is going to be E. Okay, so those are vertical angles. I'm talking about this angle here, I'm talking about that angle there. What else do you know about vertical angles? Correct, vertical angles are equal. So I'm talking about the measure of angle A, B, C, and it equals the measure of angle D, B, E. Now at this point, somebody might be thinking, well, if they're equal, I wrote congruent as congruent, okay. And congruent angles is also a fine answer here. But when you're talking about congruent, and we don't talk about the measures, you would just write angle A, B, C, congruent to angle D, B, E. So when you're talking about equals, you need to have the m's for measures. When you're talking about congruent, you do not need the measures there. All right, now I'd like you to take a minute and pause the video. I want you to draw some conclusions if you are in geometry. So what I want you to do is think about your geometry class and what types of things, when you look around, what do you see in your geometry classroom? What do these people have in common? What kinds of conclusions can you draw? And when you've written a few down, then come back to the video and let's talk about them. Okay, so let's take a look at what I have written down. I'm going to erase these. All right, if you're in geometry, you passed algebra. That is a requirement. Having passed algebra is a requirement to be in geometry. You took 7th grade math. Most of the time, everybody takes 7th grade math, and then in 8th grade is where you split up, and some people take algebra, and some people take 8th grade math. This is our second course at Platteville High School as far as the math curriculum goes. Algebra is first, second is geometry. So if you're thinking about it that way, you might be saying you are a sophomore. Right away, as I wrote these down, or I erased them, and you're looking at them, you might be saying, whoa, wait a minute, Ms. Hefty, not all those are true. Somebody in class here is a freshman, right? Sometimes we have freshmen in our class. Okay, so then that makes this false. Okay, so now I'm saying, hey, this statement is false. 3 is false. Then you have to do what is called a counterexample. A counterexample is a situation where the conjecture is not true. So right now you're saying, hey, I have a freshman in my class. You need to give a specific example. So you need to name that freshman by name. So I'm going to use Tiana. You can't just say, hey, there are some freshmen in class, but you need to give an example. Or maybe you're saying, I have a junior in class, and give the name of that junior. So you need to give a specific example, not just a general example. Okay, let's take a look at our next section. It says, read the statement. If it is false, give a counterexample. So first I need to decide if the statement is true or false. If I can find an example that's making it false, that's called a counterexample. So I have angle ABC and angle DEF are supplementary. Then A, B, C, and DEF form a linear pair. So what I'm saying here is, if I have these two supplementary angles, then they're always going to be a linear pair. So now you need to be thinking about this. Is that true that every time you have a supplementary angle, you're going to have a linear pair? At this point, you're probably saying, no, they don't have to be connected. They don't need to be a straight line. Okay, so then I'm going to draw a picture. A picture is a great counterexample. A, B, A, B, C, and then, well, they're not even going to be connected, forming a line. They have two different vertexes. And D, E, F. Now I need to be communicating that these two are supplementary, so I need to add some angle measurements here. I'm going to call that 30, and I'm going to call that 150. So this is false, and pictures are great counterexamples. So that picture right there is going to be my counterexample. Number 2, if n is a real number, then the square root of n is always going to be smaller than n, less than. Okay, at this point some people are saying, okay, real number. Oh, I don't have any idea what a real number is. You learned that in algebra. You probably learned that in 7th and 8th grade math as well. Real numbers. Those are going to be positive numbers. They're going to be negative numbers. They're going to be fractions. They're going to be decimals. Okay, so now what you need to be doing is you need to be thinking of taking square roots of numbers. And is that true that they're always going to be less than the original number? Well, if you start out and you think about the square root of 9, is that going to be smaller than 9? Yeah, 3 is smaller than 9. Okay, well, 9, so 9 works. 2 works, maybe 4 works, square root of 4 is going to be smaller than 4. Yeah, 2 is smaller than 4. Okay, so I'm trying to think of one that's not going to hold true. Can you think of one? How about 1? The square root of 1, is it going to be smaller than 1? Square root of 1 is 1. Is 1 smaller than 1? No, 1 is equal to 1. So, false. And here's my counterexample in red. Our last problem, if you have AB equaling BC, then B is the midpoint of AC. So is that going to be true all the time? Take a minute and try and draw a picture. I'm guessing what you guys have drawn right now is you've done this. You've done A, you've drawn B, and then you've drawn C, and you're saying, hey, these two are going to be the same amount. And so you're saying, hey, it's going to be true all the time. It's going to be true all the time. I don't know how you can draw this any differently so that those two, that B is not going to be in the middle. I mean, if it's going to make those two pieces equal, B is always going to be in the middle. It doesn't say they have to be collinear, that they have to be in a straight line, do they? It doesn't say that at all. It says that you have to have AB and you need BC. So I need these two pieces equal. When that happens, B is going to be in the middle. Yes, that's true in this situation, but every single picture that I draw when AB and BC are equal, is B going to be in the middle? I made this go out so that they're in opposite rays, going in a straight line. But does it have to go to the right there, guys? It does not. You could have had, and my picture's running off of the edge, but I could have put C going this way, couldn't I? And the AB and the BC, not a very good drawing, but let's assume that AB and BC are equal. Is B the midpoint at this point? It is not. So this is false, people. And again, my picture is going to be my counterexample. I don't need to always write words. I can draw pictures. Remember that your counterexample needs to be an example, not just a general statement. It can be naming something or naming an object, but you can't speak vaguely about it. All right? So you guys have a great night, and I will see you in class tomorrow.